Hello, good morning. Today we are going to see functional dependency and its types. Functional dependency is a relationship between attributes of a relation. It is introduced by E.F. Card. It helps to reduce data redundancy and improve the quality of the data in the database through normalization. FD is denoted by arrow sign. The functional dependency between attributes alpha and beta are represented by alpha determines beta, where alpha is a determinant and beta is a dependent. Here beta is functionally dependent on alpha. That means the value of b is determined from alpha. We can say alpha determines beta holds in a relation R if and only if one of the following three conditions holds. Condition 1. Either all the value of alpha must be unique. Condition 2. All the value of beta must be same. Condition 3. If two or more tuples of a relation have same value for attribute alpha, then there must be also same value for attribute beta. That is, it is represented as T1 of alpha equal to T2 of alpha, then there must be T1 of beta equal to T2 of beta. Consider this relation, student relation. It consists of student roll number, first name, last name, date of birth, email and city. First we will consider the functional dependency. Roll number determines first name. If we know the roll number, then we can tell the first name. Go through the relation, the columns of roll number and first name. The roll number column is unique. So, according to condition 1, alpha 1 is unique. So, condition 1 satisfied. So, the FD is a valid one. Consider the second FD. First name determines last name. Go through the values in the table. First name column doesn't have unique value. Similarly, last name column doesn't have same value. So, both the condition 1 and condition 2 fail. Next we move on to condition 3. If two rows are having the same value in first name, the corresponding last name value should be same. But here two rows are having the value in first name as Ram, but the corresponding last name value differs. One is Sharma and another one is Kumar. So the third condition is also failed. So this FD is not a valid one. Okay, now we will see one solved exercise. Consider the relation ABC, and among the four options, only one of the option is valid. We have to identify the option. Consider the first FD. AB determines C. In the AB column, the combination of the values are unique. So the condition 1 is satisfied. Move on to second part. C determines B. Here C column is not a unique one. Two rows having the value 5. So the condition 1 failed. Similarly, B column hasn't have the same value. So the condition 2 is also failed. For condition 3, two rows are having value as 5 in C column, but the corresponding B column doesn't have same value. One is having value 2 and another one is having value 3. So all the three conditions are failed. So the first FD is not a valid one. Next we move on to second option. BC determines A. The combination of BC is unique in every row. So condition 1 is satisfied. Move on to next part. B determines C. Here B is also unique. So here is also condition 1 satisfied. So second option is a valid one. Next we move on to third option. BC determine A. The combination of BC is unique. So the first part is valid. In the second part, A determines C. A doesn't have unique value. Similarly, C doesn't have same value. So both the conditions are failed. Next we move on to third condition. When two rows are having the same value for A, the corresponding C value must be same. Here three rows are having the value 7, but the corresponding C value differs. One of the row having 8, another two rows having 5. So the condition 3 is also failed. So option 3 is also incorrect. Next we move on to option 4, AC determine B. The combination of AC, that is unique, so the first part is valid. When we move on to the combination of unique AC, the combination of AC is not unique, so the first part itself fails, so option 4 is also invalid. So the answer is option 2. Okay, next we will see types of functional dependency. First one is trivial functional dependency. A functional dependency alpha determine beta is said to be trivial if beta is a subset of alpha. Example for trivial functional dependencies are A determines A and AB determines B. In both the cases, the right hand side is a subset of left hand side. Consider the relation employee, which consists of the attributes employee ID, employee name and date of birth. The following FDs are some of the trivial FDs. Employee ID, employee name determines employee name. Employee ID and employee date of birth determines employee ID. Employee ID determines employee ID. In all the cases, the right hand side is a subset of left hand side. Next type of functional dependency is non-trivial functional dependency. A FD alpha determines beta is said to be non-trivial FD if beta is not a subset of alpha. Consider the same employee relation. The following FDs are non-trivial FD. Employee ID determines employee name. Employee ID determines date of birth. In both the cases, right hand side is not a subset of left hand side. So it is a non-trivial FD. Next is completely non-trivial FD. A functional dependency alpha determine beta is said to be completely non-trivial if the intersection of alpha and beta is null. That means there is no common attribute between alpha and beta. Here alpha is not a subset of beta and beta is not a subset of alpha. The functional dependency AB determines CD is completely non-trivial FD. Because AB is not a subset of CD, similarly CD is not a subset of AB. A determines AB is non-trivial FD, but it is not completely non-trivial because the intersection of A and AB is A. And next one is multi-value functional dependency. In multi-value functional dependency, entities of dependent set are not dependent on each other. Consider the example A determines BC and there exists no functional dependency between B and C. Then it is called multi-value functional dependency. Consider the example FD's bike model determines color and bike model determines accessory. From bike model we can determine both color and accessory, but there is no dependency between color and accessory. So this is example for multi-value dependency. And next is transitive functional dependency. In transitive FD, dependent is indirectly dependent on determinant. If A determines B and B determines C, then according to axiom of transitivity, A determines C. This is a transitive functional dependency. Consider the FD, enrollment number determine department and department determine building number. According to axiom of transitivity, enroll number determine building number. Next, fully functional dependency. In full functional dependency, an attribute or a set of attribute uniquely determine another attribute or set of attribute. If a relation R has x, y, z with the dependencies x determine y and x determine z, which states that those dependencies are fully functional. That means both y and z dependent on x. Here x is the key of the relation. Partial functional dependency. In partial functional dependency, a non-key attribute depends on the part of the composite key. Key attribute means if the attribute is part of the candidate key, then it is referred as key attribute. If it is not the part of the key, then it is referred as non-key attribute. If the key has more than one attribute, then it is called composite key. In a relation R, there are three attributes x, y and z, where x and y are the composite key. That means xy is a key of the relation and z is a non-key attribute. Then x determine z is a partial functional dependency because actual key is xy, but z only depends on x. So it is partial key dependency. So that's the type of functional dependency. Hope you all understand the concept. Thank you.